Okay, let's look at bond pricing, and we'll do a couple equations here, and I think you'll find it pretty simple. So let's look at this example. We've got government bond pays 6 3/8%. Coupon expires December 2012. Obviously, it's an old problem, but no problem. That won't be a problem here. The par value is the original loan value. It is the value that you will be paid at the end. So it is the amount of money borrowed at the beginning of the loan and the amount that will be paid at the end. So that's par value. Par value is $1,000. Coupon payments are semi-annual, as is all the coupon payments in this class. The coupon rate is 6 3/8, as we said, and the payment is $31,875. We will explain $31,875 in 2 slides, I think, but I'll explain that to you in a second. And you can see the timeline here. The timeline starts January 1st, 2008, and it pays $31,875 every 6 months until we get to December 31st, 2012, in which case it gives you your final interest payment and your $1,000 back. So it's $31,875 for 9 payments. The 10th payment is your money back plus the last interest payment. Now, all we have to do, now that we have the cash flows, is discount those back to the present value to find out the value of our bond. However, we can do it 2 ways. One is the formula that's shown here at the bottom of the slide, which looks a little complex and hard to get into a calculator and not very quick to adjust. Or we can do it the easy way. We like the easy way. I know we like the easy way. Okay, so here it is. It's just a simple time value of money problem. So in this case, we're looking for the present value, so PV. We're looking for N. N is 5 years, and so it's semi-annual 5 years. So how do we get 10? Well, 5 years semi-annual, 5 times 2 is 10. The interest rate, the problem is set up is the yield to maturity is 5%. The yield to maturity is today's interest rate. Yield to maturity is today's interest rate, and it's set by the market, and it's in this problem 5%, and that's 5% annually. So if it's 5% annually and we're semi-annually, what do? You divide by 2, and you get 2.5%. So the yield to maturity is today's market rate. Present value is what we're looking for. The payment, I told you we would get to this. Payment is very simple. The 6 3/8% the bond is paying. The 6 3/8% the bond is paying is multiplied by a $1,000 bond. So you borrowed $1,000 and I'm paying you I borrowed $1,000 and I'm paying you 6 3/8% per year. So that's how much I owe you per year. And if I divide that by 2, I can find the payment every 6 months. So 6 3/8 is kind of an odd number. An example, a round numbered example that's easier to follow is if it was $1,000 and 10% interest, the interest per year would be $100. And if you paid it every 6 months, it would simply be $50. So you can see that the calculation for coupon payment is quite simple. You take the coupon rate, a loan rate, the rate that was issued for the loan, and you multiply it by $1,000, and then you divide by 2 to get it semi-annually. So coupon payments are quite simple to figure out. And of course, you've got the $1,000 for the future value. Now you have 4 of your 5 variables, and you can see that the answer is $1,060.17. And of course, it's negative because the money is going in an opposite flow. So money coming in is negative, money coming out is positive. One of the two has to be negative. So you start thinking about this in the positive negative flow of money in this situation. And your payment and your future value, are they going in the same direction? Yes, they are. So if you issued the loan, you would be receiving the $31,875 and the $1,000. Or if you gave the money to the corporation, you would be receiving the $31,875 and the $1,000. And from the corporation's point of view, they would be paying the $31,875 and the $1,000. So those move together, and the opposite is the $1,060. So if I were to sell this bond, I would receive the $1,060 instead of the $31,875 and the $1,000. Okay, so that's clear as mud, I'm sure. So let's keep going and do a different example. Now assume that the yield to maturity is 11%. How does this change the bond's price? Well, the original value or the interest rate of the bond was 6 3/8. It has fallen to 5%. So we found out that it was worth $60 more because it had fallen a little bit. Well, now the interest rate, still paying 6 3/8%, is at 11%. So the interest rate is higher. So a person in the marketplace could go in and say, well, do I want to buy your bond that pays me 6 3/8%, or do I want to buy a new bond that pays me 11%? Well, I'd rather have the new bond that pays me 11%. So the only way you can sell your 6 3/8% bond is by giving a discount. So how much of a discount? That's another time value of money problem. We simply plug that in. All the variables are the same except one. The I over Y changes. It was 2.5 times 2 for 5%. In this case, it's 5.5 times 2 for the yield to maturity of 11%. And you can see that dramatically changes the value of your bond. It was $1,000 at par when you issued it, or when it was issued and you bought it, and it went to $1,060 when interest rates fell. And now that interest rates have risen, the bond is now worth only $825.69 if you wanted to sell it. And you don't have to sell the bond. You can hold on to the bond, and at the end you'll get your $1,000 back. But if you want to sell it before then, the bond value, the only thing the market will pay you, is $825. So you can see this example of bond prices and interest rates moving inversely. That when the interest rate moved down compared to the loan value, the coupon interest rate, when that interest rate moved down, the bond price moved up. And when the interest rate moved up, the bond price moved down. That's how they work. They are exact inverse opposites. When interest rates rise, bond prices fall. The value of the bond falls. If you hold to maturity, you'll always get your money back, assuming the company doesn't default. You'll get your whole money back, but you have to hold to maturity. And in some cases, that can be difficult because you're holding a 6 3/8% bond while everybody else out there has 11% coming in, and you might feel a little you're unfortunate in that case. So this is how to price bonds. We'll do some more problems coming up in the future. Let's keep going.